Right, we have this particular derivative to evaluate. We have been given d dx of the expression x to the power x, and we need to present a solution to this particular derivative in a step-by-step fashion. Right, and we proceed as follows. Right, we've been given this particular derivative to determine. So we have d dx of x to the power x, which is d dx of e to the power the ln of x to the power x. And this is d dx of e to the power the ln of this. Okay, so this is possible. And we proceed now to evaluate the derivative of this expression. But the derivative of the E expression is determined by using the chain rule of differentiation. And then we have d dx. Right, of e to the power x ln x. What is this derivative? Right, the derivative of the E is just the E multiplied by the derivative of x ln x, like so. Okay, this one is a product here, and we shall use the product rule of differentiation. Okay, so this is ln x. Now, let us find the derivative of the product there using the product rule of differentiation. So the derivative of the x is 1 times ln x plus x, and then the derivative of 1 over x or of ln x becomes 1 over x. Okay, now x times 1 over x becomes 1, and then this is actually the same as e to the power x ln x, and this then is here 1 times ln x becomes ln x, and this x cancels, giving us a 1. So we have within the parentheses ln x plus 1. Okay, so we have ln x plus 1. All right, now, moreover, we continue to simplify this, and it is e to the ln x to the power x, and this is ln x plus 1. Right, now e to the power ln x to the power x is the same as x to the power x ln x plus 1. Okay, so that is what we get here. Okay, so we continue right now to simplify these in the best way possible, and we achieve the following. Right, so after having obtained this, then we're able to make the following conclusion. Hence, right, hence, d dx of x to the power x is x to the power x, the ln of x plus 1. Right, so this becomes the derivative of this. Okay, right, and this becomes the what? The derivative of this. And simultaneously, so this becomes extremely important for us to consider this. And I must indicate, therefore, that this is the answer, is the solution to the problem. And we've been able to solve this particular problem in a step-by-step fashion. However, there are a couple of remarks that we can make here, as a matter of fact. For example, one can, in other words, the derivative is if the derivative is actually in this direction, we can be able to perform what you call integration. So this one is the derivative. And if you have the derivative, you want to obtain the original function, this becomes what? It becomes what you call integration. Right, so that is integration. Right, so this becomes the derivative, and the process is called differentiation. Okay, now And the process of finding what this original function is called integration, and this function is called the integral. Okay, now, as a consequence, a couple of things that are very important. So it means, let us just put this remark. Okay, this is just a remark. Right, we put this remark. And we've seen, therefore, that d dx of x to the power x is x to the power x times the ln of x plus 1. And this is d of x to the power x, which equals x to the power x, which is ln x plus 1 dx. So, which means that is x to the power x. If you have x to the power x, ln x plus 1 dx. So in other words, if you find, so we can look at it this way. Okay, let us just give a brief comment here. This is a very important occasion. We can decide, therefore, to find the integral here and the integral this side. Right, so that now the integral of this becomes the integral of x to the power x ln x plus 1 dx, and this is x to the power x plus c. So in other words, this means that you can take note of the fact that if you find the integral of this, it becomes so exactly that. Okay, so in other words, if you find the integral of x to the power x into ln of x plus 1 dx, this is x to the power x plus c. Okay, so a very, very interesting integral to note there. Okay, and this here obviously becomes the associated integral. So if you find the derivative of this using the d dx notation of x to the power x, the derivative becomes this. And therefore, if you find the integral becomes this. Okay, right. We are thrilled and excited that we've been able to solve this problem. Thanks, everybody, for joining us. And this is awesome news. And goodbye to you.